Okay, I'm going to go over a method of factoring that is kind of confusing, and a lot of people don't teach it this way, but I think it can be helpful in your first learning. It gives you a step-by-step process, and it's called slide, divide, slide. Slide, divide, slide. And so what you want to do is first make sure your leading coefficient is positive. So I'm going to factor out a negative here. Okay. And then what I'm going to do is I'm going to slide, that's this part, I'm going to slide the 15 over onto the negative 18, and just grab a calculator if it's helpful. 15 times 18 is negative 270. And now I'm looking for factors of this 270 that give me a sum of 17. But remember, one has got to be positive and one has got to be negative. So you're actually subtracting to get to 17. So it looks like it's going to be 27 for the negative and 10 for the positive. Those will multiply to give me this, and the difference there, they'll add up to this. Okay, now I'm going to do this. I have that negative there, and then I'm going to put x plus 10 and x minus 27. Okay, but I'm not done yet. That was just the slide part. Now I'm going to do the divide part. I'm going to divide each side by the number that I slid over. And I slid over a 15. Okay, so I'm going to divide by 15. And then I'm going to reduce the fraction if I can. So this becomes negative. We have x plus, dividing by 5 gives me 2 over 3. X minus dividing by 3 gives me 9 over 5. And finally, I'm going to slide. So I'm going to slide this. I'll slide this number back here like this. And I'm going to get negative. That 3 goes out in front, plus the 2 up there. And that 5 goes out in front, minus 9 here. I know that's a weird process, and not many people will teach it that way. But that's going to give you a step-by-step process of getting to this. Again, I'm going to use slide, divide, slide. So I'm going to start by taking my 10 and sliding it over to negative 18, and I get negative 180. Then I'm going to factor out negative 180. Remember, one's got to be positive and one's got to be negative. And I'm looking for numbers because they're opposite signs that give me a difference of 3. So I think it's 15 and 12, but let me just take 180 and divide by 15. Yeah, it's 15 and 12. And the 15 has got to be positive, and the 12 has got to be negative, so that when I add them up, I get to a positive 3. So what I've got so far is x plus 15 times x minus 12. That's the slide part, okay? Then I'm going to do the divide part. I'm going to divide each of the numbers by what I slid over. I slid over the 10, so I'll divide each one by 10. And then I'm going to reduce the fractions if I can. So I have x plus, dividing by 5 gives me 3 over 2. X minus, dividing by 2 gives me a 6 over 5. So that was the divide part. Now the slide, I'm going to take that and slide it back. I'll take the denominator, if there is one, and slide it right back. And that's going to end up with 2x plus 3 times 5x minus 6. And that's the answer. Now, and again, you can always check. If you get confused and you're not sure if it works, FOIL this. The first is 15x squared. The outer is a negative 12x. The inner is a positive 15x. And notice, by the way, those two middle terms were the factors you found there. The last is negative 18. These are going to become the 3x. So you have 15x squared plus 3x minus 18. So you know it works. So again, I'm going to use slide, divide, slide to do this. I'll take the first number, the 8, and I'll slide it over, and we'll get 8 times 35. I'll just grab a calculator, and I get 280. So now I'm factoring, they're both positive. I know that because this is positive, so I know the signs match, and that's positive. So I know they're both positive. That means I'm looking for factors that are going to add up to 34. So both of the factors have to be less than 34. Let's see. I'm going to hit pause here for a second. Actually, you know what? This is a real problem and it's very difficult. So I'm going to just start, listing examples. 10 and 28, but that adds up to 38. Let's see if 280 is divisible by 12. Nope. 280 by 15. Nope. 280 by 16. Oh, I should have done 280 by 14. Yep. 280 by 14 is a positive 14 and a positive 20, and those add up to 34. This right here is the hardest part. But once you found those factors, you're basically done with the problem. Now I'm going to say x plus 14 and x plus 20. And you can just use a calculator and common sense to kind of zero in on the two factors that you're after. All right, that's the slide part. The divide part, we're going to divide each side by what we slid over, the 8. So we'll divide by 8, and then we'll reduce the fractions if we can. So dividing by 2 gives me 7 over 4, and dividing by 4 gives me a 5 over 2. Now that those are simplified fractions, we're going to do the slide part. We're going to slide the denominator back, if there is one. And that denominator goes out in front. So we end up with 4x plus 7 times 2x plus 5. And it's hard to squeeze in there, but that's the final answer. Oops. This was k, so that should be 4k plus 7 and 2k plus 5. Okay, again, I'm going to do all of these with slide, divide, slide. Okay, so the slide part is I'm going to take the 20 and slide it on over. So this slides over, and I'm left with, let's see, 48, so 480. So I know that both my factors are positive because this tells me they're the same, and this tells me they're both positive rather than both negative. So when this is positive, they both have to be positive or both negative. This tells me which. All right, so I know I'm adding up to 47. So both my factors have to be less than 47. So let's just start fiddling with numbers. I'm going to start with 24. 480 divided by 24 is 20. But that's not it. That's going to add up to 44. Let's see. Let's see if 480 is divided by 25. Nope. 480 divided by 26. Nope. 480 divided by 27. Nope. 480 divided by 28. Nope. 480 divided by 29. 480 divided by 30. Okay, and I got 480 divided by 30. So 1 is 30, possibly. Where's my pen? Oh, my pencil just went offline. Give me a second here. Okay, so 1 is going to be 30, and 1 is 16. But that adds up to 46, so it's still not there. So let's go 480 divided by 31. No, 480 divided by 32. That's, let's see, 32. The other is 15. My pencil keeps going offline. And that's it. So I have x plus 32 and x plus 15. Again, this is the only real work, but you can use a calculator to find those factors. Now that I did the slide, I'm going to do the divide. I'm dividing by what I slid over, which is the 20. So I'll divide these by 20. My pencil needs to be charged. And I'll reduce the fractions if I can. So I have Dividing by 4, I get 8 over 5. Dividing by 5, I get 3 over 4. And then I'm going to divide. So I'll take, my pencil keeps, and I'll recharge my pencil after this. Let me pause this video, recharge my pencil. Okay, so that's the divide part and the reduce. Now we're going to slide. And I'll take the denominator and slide it back, if there is a denominator. And we'll end up with 5x plus 8 times 4x plus 3. Okay, slide, divide, slide. I'm going to start by taking the 27 and sliding it over onto the negative 5 to give me negative 135. And because they're negative, I know I'm subtracting to get to 42. So one of the factors has got to be bigger than 42. So one has got to be positive and one is negative. Because this is a positive 42, the bigger one has got to be bigger than 42. So I'm going to try numbers like, say, 45. I'll just grab a calculator and go 135 divided by 45, and I get 3. And that works. Okay, now, so I have x plus 45 and x minus 3. And then I'm going to divide by what I slid over, the 27. So I'm going to reduce the fractions if I can. Dividing by 9 gives me 5 over 3. And dividing by 3 gives me 1 over 9. That's the divide part. Now the slide part. I'm going to take, if there's a denominator, I'm going to take it and slide it back in front. And I'm going to end up with 3x plus 5 and 9x minus 1. Okay, this b, don't worry about that till the end of the problem. You'll see how that works in just a second. But I'm going to take my 15 and slide it on over to the positive 8. And I'll get a positive, let's see, 80 plus 40 is 120. And now when I'm looking for factors, I know both my factors have to be negative. That's because this is positive, so these have to match, both positive or negative, but this tells me they're both negative. So I'm looking to add up to get to 22. That means both of my factors have to be smaller than 22. So let's look at 12 and 10. Okay, so I'm going to have x minus 12 and x minus 10. That's the slide part. Now the divide part, I'm going to divide by the number I slid over, which is the 15. So I'm going to take that and divide by 15. And I'm going to reduce this fraction if I can. Dividing by 3 gives me 4 over 5. Dividing by 5 gives me a 2 over 3. Then if there's a denominator, you're going to take it and slide it back. And you're going to end up with 5x minus 4 times 3x minus 2. Okay, I'm going to do these with slide, divide, slide. By the way, this is not the only way to do these problems. So I'm going to start by sliding the 15 over. I slide 15 onto positive 8 and I multiply and I get positive 120. Just use a calculator if you need to. This tells me they're both the same sign, both positive or both negative. This tells me they're both positive. Because they're the same, I know I'm adding up to 120, so each of my factors has to be smaller than 24. So I'm thinking of things, I got to think of factors smaller than 24. Let's see. How about, so in other words, I'm not going to think of things like 60 and 2 because 60 is too big, or 30 and 4 because 30 is too big. How about 20? 20 and 6 is a reasonable thought, but it's not going to work because that adds up to 26. So let's see if this is divisible by 18. 240 divided by 18. Nope. 240 divided by 16. So 240 divided by 16. So 16 and 15. Wait a minute. 120. Oh yeah, 16 and 15. That adds up to 31. That's not going to do it. Actually, there are no, because I got down to this and it's 31, and this is 26, and it's not divisible by 18, there are no factors that are going to add up to 120. So this is prime. And that happens sometimes. And if you're on the test, you might as well, if you can't figure something out, guess prime, because that might be the answer. But this cannot be factored because there are no factor pairs of 120 that are going to add up to 24. I can see the answer here without doing any work, and that's because this is a perfect square and this is a perfect square, which means I might have a perfect square. The square root of this is 6m. The square root of this is 5. This sign goes in between. Now, this might be the answer. In order to determine if it's the answer, I got to see if this 60 works out. And the way you see if it works out is you take the product of these two things, which is negative 30, and then you double it up. If after multiplying these and doubling it, you get to this is the answer. Okay, not everybody's going to see that. If you didn't see that, you can do slide, divide, slide. Slide over the 36. 36 times, this is going to be really big numbers though, so hopefully you see it the other way. 36 times 25 is 900. So you end up with a positive 900 here. And you're trying to factor, they both got to be negative because this is a positive and that's a negative. And they're both trying to add up to 60. So 30 and 30. That multiplies to 900 and it adds up to 60. And then so you're going to have x minus 30, x minus 30. Now we've done the slide part. The divide part is dividing by what we slid over, the 36. So I'm going to divide this by 36. And then I'm going to reduce the fraction if I can. Dividing by, let's see, 6 gives me a 5 over 6. Dividing by 6 gives me another 5 over 6. And then I'm going to do the slide part. I'll slide this back and I'll get 6x minus 5 times 6x minus 5, which is 6x minus 5 squared. Oh, except that these are not x's, these are m's. You just think, in fact, let me just change this. Or you could have written it like this. Here we have another problem where the outside terms are perfect squares. When the outside terms are perfect squares, you might have a perfect square. You put the square root of this first, 5r. You put the square root of this next, 9. And you put this sign in between them. That might be the answer. You don't know for sure until you check the middle term. You take the product of these and double it and see if you get that. This times this is negative 45r. Doubled up is negative 90r, so that we know is the answer. But you really do have to check that middle term to see if it works. Just because this and this are perfect squares doesn't mean that this is the answer. You've got to check that middle term. Don't worry about that variable. Worry about that at the end of the problem. I'm going to multiply this over here and I'm going to get 240. Slide that over and I get a positive 240. Because that's positive, these both have to be positive. And there are no factors. This is a 1 here. There are no factors of 240 that are going to add up to 1. It's just impossible. And hopefully that's super obvious to you. So this is prime. Again, worry about that D after the problem is over. The first thing I'm going to do is slide this over. 14 times negative 6. I'll just grab a calculator. And I get negative 84. Because it's negative, I know my factors. One has to be positive and one has to be negative. Because this is negative 17, the bigger one has to be negative. So, and one of the factors, the bigger one, has to be bigger than 17. So when I'm looking at this, I'm going to do things like 21 and 42 and things like that. I'll try 21 first. That's 21. The other has to be 4 because that adds up, multiplies to negative 84. And sure enough, these add up to negative 17. So we're done. So we say x plus 4x minus 21. That's the slide part. Now we're going to divide. We're going to divide by what we slid over. So we'll divide each of these things by 14. And then we'll reduce the fractions if we can. Dividing by 2 gives me 2 over 7. Dividing by 7 gives me 3 over 2. And then we're going to slide the denominator if there is one. There's not always going to be one, but if there is one, we slide it back. So we get 7x plus 2 and 2x minus 3. I said not to worry about that, but now we have to worry about the d. So this d is going to go here. So let me rewrite this. We're going to have 7x plus 2d and 2x minus 3d. And you can FOIL that out, and you'll see that this will turn into exactly that. Here we have an x squared z squared. Don't worry too much about that. I'll show you how that works at the end of the problem. Let's just do the same thing. We're going to slide this over and get negative 24. So one has to be positive and one has to be negative. And the difference has to be 5. So the positive one has to be bigger than 5. So how about 6 and 4? No, 8 and 3. 8 and 3 does it. So we have positive 8 and negative 3. So we have x, well, let's worry about, I'll do it like this. xz plus 8 and xz minus 8. That's because xz times xz is x squared z squared. Now, that's the slide part. We're going to divide by what we slid over. We're going to divide by the 6. Oops, this is a 3. Excuse me. Okay? So now I'm going to reduce the fractions if I can. So we have xz dividing by 2 gives me 4 over 3. xz dividing by 3 gives me 1 over 2. And then if there's a denominator, we're going to take it and slide it back. I didn't give myself very much room for this, but we're going to end up with 3xz plus 4 and 2xz minus 1. Okay, slide, divide, slide. I'm going to start by sliding the 8 over to give me positive 24. So now my factors are they're both the same because this is positive, right? So they both got to be the same, but they're both negative because that's negative. So now because they're the same, I know I'm adding up to 10. So what are factors of 24 that add up to 10? Well, 6 and 4. So I'm going to have mn minus 6 and mn minus 4. That's because mn times mn is m squared n squared. So that's the slide part. Now we're going to divide by what we slid over. We'll divide by that 8. And then I'm going to reduce this fraction if I can. Dividing by 2 gives me 3 over 4. Dividing by 4 gives me 1 over 2. And then if there's a denominator, you're going to slide that denominator back. And we're going to end up with 4mn minus 3 and 2mn minus 1. First thing we'll do is a slide. These numbers are pretty big. Actually, notice that there's a 3 divisible by all of these. So instead of multiplying it out first, I'm going to factor out that 3 is going to have to come out at some point. I might as well do it first because it's going to make this problem a lot easier. So because 3 can come out, I'll take a 3, and we have 8x squared plus 14x plus 5. Now, see, 24 times 15 was an enormous number, but 8 times 5, that's 40. That's easy. So we'll multiply the 8 times 5 and we get positive 40. Because it's positive, they're both the same. This tells me they're both positive, which means they're adding up to 14. So 10 and 4. So don't forget about this 3 sitting out in front. But we have x plus 10 and x plus 4. That's the slide part. Now the divide part, we're going to divide by what we slid over, which was the 8. And so I have that 3 sitting out there. Dividing by 2, we're going to get 5 over 4. And dividing by 4, we'll get 1 over 2. Now we'll do the slide part. Slide the denominator back if there is one. And we'll end up with 3 times 4x plus 5 times 2x plus 1. Again, 36 times 4 is a big number, but take a look. These are all divisible by 2. So I'm going to start by taking the 2 out. This will be 18x squared plus 9x minus 2. Now that there's no common or factor, I'll take the 18, and this gives me a negative 36. That means one has to be positive and one has to be negative, and I'm going to be subtracting to get to my middle number of 9. The bigger one, because this is positive 9, this has to be bigger than 9. So let's say 12 times 3. Positive 12 and negative 3, those multiply to negative 36, and they add up to positive 9. So far I have that 2 that's sitting out there, and I have x plus 12 and x minus 3. That's the slide part. Now the divide. I'm going to divide by what I slid over, which was, in this case, the 18. And then I'm going to reduce the fractions if I can. Dividing by 6 gives me 2 over 3. Dividing by 3 gives me 1 over 6. And then I'm going to do my slide part. I'll slide the denominator back if there is one. And I'm going to get 2 sitting out there, 3x plus 2, and 6x minus 1. Okay, a couple of things with this problem. First of all, I can see that they're all divisible by 5. And my leading coefficient's negative. I don't want that to be negative, so I'm going to factor out both a 5 and a negative. So I factor out a negative 5 and leave behind a positive 3a squared plus 14a minus 24. Now, there's no common factor, and my leading coefficient is positive. So now I'm ready to do my slide, divide, slide. I'm going to slide by sliding this 3 over to the negative 24, and we'll get negative 48, 72. Because it's negative, one is positive, one is negative. This is positive here, so the bigger one's got to be bigger than 14. And then I'm going to be subtracting to get to 14. So let's see, 24 and 3, that would be 21. How about 18? Let's see if 18 goes into here. 72 divided by 18 is 4. So positive 18 and negative 4. Those multiply to negative 72, and they add up to negative 14. So I have my negative 5 sitting there, and now I have, this is an a this time, so a plus 18 and a minus 4. That's my slide part. My divide is I'm going to divide by the number I slid over, which was the 3 this time. And then I'm going to reduce those fractions if I can. Actually, this one can't reduce, so I just leave it alone. Now, this one doesn't have a fraction, so I don't do anything with this, but this has the denominator, so I'm going to slide that back over. And I'm going to end up with negative 5 times a plus 6 times 3a minus 4. For number 34, there's a 2 that's divisible to all of these, and this is negative. I don't want that to be negative, so I'm going to factor out a negative 2. That leaves behind a positive 6a squared plus 5a minus 21. Okay, now this is positive, and there's no common factor. It's all out here. So now I'll do my slide. I'm going to take the 6 and multiply, and I'll get negative 126. Because it's negative, 1 is positive, 1 is negative. So I'm subtracting. One of them has to be bigger than 5. Well, probably both bigger than 5. Let's see. If you can't see it, just start factoring out any numbers that you can see. Like, for example, 63 and 2, but that's not going to be even close. 126 divided by 3 is 42. That's not even close. 126 divided by 4. Nope, that's not divisible. 126 is not divisible by 5. Let's see if it's divisible by 6. Yeah, 6 and 21. That's we're zeroing in, but we're not there. How about 126 divided by 7? It's not going to work. 126 divided by 8. That's not. 126 divided by 9. So that's 14. Oops, what did I just do? And that is the 5 that we're after. Okay? So that took a little bit of work, but we found it. These two numbers multiply to this, and they add up to that middle number. So we're almost done. We have the negative 2 on the outside. We have a plus 14 and a minus 9. Now we did the slide. Now we're going to divide. So we'll divide these by what we split over, the 6. And we'll reduce those fractions if we can. Dividing by 2, we get 7 over 3. And dividing by 3, we get a 3 over 2. Now we're going to slide this back. And we're going to end up with negative 2 times 3a plus 7 and 2a minus 3. I can see we can take out an x. 11 comes out of here. I can see 11 comes out of here. I'm going to use a calculator to see if 11 comes out of 264. So 264 divided by 11, 264 divided by 11 is 24. So I'm going to take out an 11x because that's what's common. That leaves behind an x squared minus a 10x plus 24. Now, I don't even have a leading coefficient, so I don't need to do slide, divide, slide. I'm simply looking for factors of 24 that add up to negative 10. So there I know they're both negative, and it looks like a 6 and a 4. Those multiply to positive 24, and they add up to that. So now I'm done. So I have 11x times x minus 6 and x minus 4. And that's I didn't have to use a slide, divide, slide process because there was no leading coefficient over here to slide over. So this is all I had to do. Okay, in this problem I can see there's a k that can come out of everything. And I believe 9 as well. 9 comes out of here. I'm going to double check here. Oh yeah, I can see it comes out. So I'm going to take out a 9k. That leaves behind a k squared plus 4k minus, let's see, 9 goes into 18 twice, into 9 once, so that like that. Now there's no leading coefficient, so I don't even need to use slide, divide, slide. I'm just looking for factors of 21 that give me a 4. So positive 7 and negative 3. So I'm done. I have 9k, k plus 7, k minus 3. I can see that all of these are even, so I know a 2 can come out. And then, let's see, we have x cubed squared x. A single x can come out. And we have a y cubed to the 4th to the 5th. The smallest of those is 3, so y3 can come out. And that's going to leave behind an x squared minus a 24xy plus a 144 y squared. Now, there's a 1 in front of here. This is a 144. That's a perfect square. This is a perfect square, so I might have a perfect square. I might have x minus 12y squared for this part, because this squared is this squared is this, and this times this is negative 12xy, and when we double it, we get to that. I don't know if you remember that trick from earlier, but that's how you tell that you have a perfect square there. And then don't forget about that. So that's the final answer. Again, when you see that the first term's a perfect square and the last term's a perfect square, you can put the square roots down. The middle sign goes there. To check if this is in fact how it works, you multiply those two together and double it to see if you get that. These two multiplied together is negative 12xy. Double it is negative 24xy. So that's the answer. Okay, I can see a 6 can come out of everything. So I'll start by taking out a 6. Then when we look at the m's, I have m3, 2, and 1. 1 is the least, so I can take out a single m. And when I look at the n's, we have 2, 3, and 4. 2 is the least, so I can take out an n squared. That leaves behind an m squared minus 4mn minus 5n squared. Now, I don't have a leading coefficient, so I don't need to use slide, divide, slide. I'm just looking for factors of this that give me a difference of 4. So negative 5 and positive 1. So I'm basically done. I have 6mn squared times m minus 5n. I have to put the n there because we need to get to an n squared. And then I have m plus 1n, but we don't put 1, we just put n like that. This is our 1n, and this is our negative 5n. Okay, you see how this k plus 1 is recurring? So I'm going to start by saying let x equal k plus 1. Then I have a 10x squared minus 7x plus 1. And I can factor this. If you want to use, if you want to use slide, divide, slide, you can. You multiply that over and you get a positive 10. So you're looking for factors of 10 that add up to negative 7. So negative 5 and negative 2. So what you have is x minus 5 and x minus 2. The problem is this didn't have an x in it. Now we have to replace this x with what x is, k plus 1. So we end up with k plus 1 minus 5 and x, which is k plus 1, and then we have minus 2. And finally, we have to simplify these. Plus 1 minus 5 is minus 4. 1 minus 2 is negative 1. So that's the final answer. Okay, here's our recurring element. So I'm going to say x is equal to m minus 5. And then what I've got is a 4x squared minus 4x minus 15. And I'm going to factor this. So I'll start by sliding this over, and I'll get negative 60. 4 times negative 15 is negative 60. So one's positive, one's negative. Because this is a negative, the bigger one's got to be bigger. The bigger one's got to be negative. So let's see. How about 12 and, no, 10 and 6. So 10 and 6. Those multiply to negative 60, and they add up to negative 4. So what I've got so far is x plus 6 and x minus 10. But again, there's no x in this. So now I have to replace the x with what x is, m minus 5. So this is going to be m minus 5. So we have m minus 5 plus 6, and this x is m minus 5, but then we have minus 10. And then we're going to combine like terms. Negative 5 plus 6 is a positive 1. Negative 5 minus 10 is a negative 15. And that's the final answer. Okay, here's our recurring element. So I'm going to start by saying x is equal to m plus p. And then I've got 3x squared minus 7x minus 20. I'll start by sliding that over and give me negative 60. That means that one's positive and one's negative. I'm trying to subtract a negative 7. So let's see, 12 and 5. 12 and 5 multiply to negative 60, and they add up to negative 7. And this is what's going to take you your mental energy, doing that. But once you've got that, the problem's almost done. So now we've got x plus 5 and x minus 12. That's the slide. And then we're going to divide by what we slid over. We're going to divide by that 3. Then you reduce the fraction if you can. This one doesn't reduce. This reduces the 4, so I'm just going to slide this back while I'm at it. Oops, what did I just do? This I'll slide back and I'll get 3x plus 5, but this one simply reduces to minus 4. Now this would be the answer, except that remember there's no x in here. Now we have to replace x back with what we have. So this x becomes m plus p. So this is a little tricky, so I'm going to write it like this. M plus p, that's our x. Then we have this plus 5, and then we have this m plus p, and then minus 4. Then we'll distribute this and get 3m plus 3p plus 5 and m plus p minus 4. And that's our final answer there. Okay, here's our recurring element. This is x, so I'm not going to use x equals. Let's say I'll use a. So I'll have a equals x minus y. And now what I've got is 4a squared minus 23a minus 6. I'll slide the 4 over and I'll get negative 24. So that means one's positive and one's negative. So this is 24 and positive 1. Hopefully that's obvious, because that's the only way to get to 23. So what I've got so far is a plus 1 and a minus 24. But then remember, we've got to divide by what we slid over, that 4. This I can slide back and give myself 4a plus 1. But this is reducible, so I'm going to reduce that and give me a minus 6. Okay, this would be the answer, except that there's no a here. So now I've got to take x minus y and plug it in for this. So what I've got here is 4 times my x minus y, but then we have this plus 1, and then we have this x minus y, that's our a, then we have our minus 6. And then we'll distribute this. And we'll get 4x minus 4y plus 1 times x minus y minus 6. And nothing is left to be simplified, so that's the answer. Okay, this a plus b is the recurring element. So I don't want to use a or b, so I'll use x. X is equal to a plus b. So what that gives me now is that I have a squared times x squared, well, let's do it like this, minus ab times x minus 6b squared. There's a coefficient of 1 out here, or is actually an a squared out here, but really what I'm looking to do is find factors of negative 6 that add up to 1 here. So this is going to be a positive 2 and a negative 3. Those will add up, those will multiply into this, and they'll add up to 1. So what I've got right now is I've got that's a positive 2. So I have a positive 2ax oops, I'm sorry, an ax. What did I just do? I have an ax plus 2b and an ax minus 3b. I had to throw the b in there to get to b squared, but this is our positive 2 and that's a negative 3. I needed an ax here because I need to multiply this to become a squared x squared. All right, now this x needs to be replaced because x is a plus b. So now this is really confusing, but what I've got is a times x, which is a plus b, that's our x. Then we have plus 2b times a times our x, which is a plus b minus 3b. And I'll take this and distribute, and we've got a squared plus ab plus 2b. I'll distribute this, and we have a squared plus ab minus 3b. And that's a really tough problem. You will not be asked to do anything that tough on the test. Okay, our recurring element is m minus p. So I'll say x is equal to m minus p. And now we have m squared times x squared plus mp times x minus 2p squared. So I've got mx. Now, factors of negative 2 that add up to positive 1 are positive 2 and negative 1. So this has got to be a plus 2p, that's for this, minus 1p. All right, this would be the answer except there's no x. I have to replace this x with m minus p. So I have m times our x, which is, oops, what did I just do? Times our x, which is m minus p plus 2p times m times our x, which is m minus p minus p. I'll distribute this, and we have m squared minus mp plus 2p. I'll distribute this, and we'll have m squared minus mp minus p. And there's no like terms, so that's the final answer. And again, that was an extremely difficult problem. You're not going to be asked to do anything that difficult on the test. Okay, I'm going to start by slide, divide, slide. I'll slide this 2 over and I'll get negative 36. So one's positive, one's negative, and I'm looking to subtract, so 12 and 3. The 12's got to be negative and the 3's got to be positive because it's got to be adding up to negative 12, not positive 12. This is an x to the 4, so I have x squared plus 3 times x squared minus 12. Then I've got to divide by what I slid over, the 2. And this is going to reduce, but this is not. So this one, the denominator's got to slide down across, and I'm going to get 2x squared plus 3. But this is going to reduce, so I don't slide that over. I just if you can reduce the fraction, you have to reduce it, or you'll get some weird, wonky answer. Okay, so I'm going to slide this over, and we'll get negative 6. Factors that add up to, this is a 1 here, so positive 3 and negative 2. So I've got z squared, let me put this in red. I've got z squared plus 3 and z squared minus 2. And remember, that's because this is negative 3 times 2 is negative 6, and these add up to the 1 that we're after. Okay, now we got to divide by what we slid over, so we got to divide by the 6. And then you reduce the fractions if you can. Z squared plus 1 over 2 and z squared minus 1 over 3. Then if there's a denominator, you got to slide it back. So you end up with 2z squared plus 1 and 3z squared minus 1. Okay, for number 47, we're going to slide the 16 over, and we'll get 48. And then we're going to factor this as 12 and 4 because those multiply to 48, but they add up to the 16. So here we have x squared plus 12 and x squared plus 4. So now we've got to divide by the number that we slid over, which was the 16. And then we're going to reduce those fractions if we can. Oops. X squared plus, dividing by 4 gives me 3 over 4. Dividing by 4 gives me 1 over 4. And then we're going to slide that back here, and we're going to end up with 4x squared plus 3 and 4x squared plus 1. And that's it.